Hi, and welcome everyone to today's exciting webinar with Vultr and Domino Data Labs. Here today, we are here to discuss unleashing AI innovation at scale and how you can accelerate time to value by integrating DevOps, CloudOps with the market-leading MLOps platform from Domino. Now, before we get started, it's important to note that this webinar is being recorded. We also encourage all of you to ask as many questions as you can during the chat. And at the conclusion of today's presentation, we'll go through the chat and answer as many of the questions as we can. And we look forward to seeing many, many questions in the chat. So let me just introduce our speakers today. So first, my name is Kevin Cochran. I'm your host for today. I'm the Chief Marketing Officer here at Vultr, and I'm very pleased to be joined by two very critical members of the Vultr and Domino team. First up, speaking on the Vultr side, is Duncan Eng. Duncan is our Director of Solutions Engineering here at Vultr, our field CTO working one-on-one with customers in the field, helping them realize amazing value and getting the most cost-efficient, highly performant, independent cloud compute platform on the planet. We're also very lucky to be joined by Domino Data Labs' Josh Minaroth. Josh is the head of technical alliances at Domino Data Labs, and he's going to be taking us through their MLOps platform as well as a very exciting demonstration. So here on today's webinar is a relatively simple agenda. We're going to learn all about Vultr and Domino Data Labs. We're going to first start with a brief overview of Vultr from Duncan, followed by a brief overview of Domino from Josh, and then a very detailed walkthrough of the Domino platform. And then we'll conclude with some next steps on how you can get started. And of course, as I mentioned, address all of your questions in the chat through our Q&A. So with that, I'd like to hand it over to my fine colleague, Duncan. So Duncan, over to you.
Thanks a lot, Kevin. So what we'd like to discuss today is revolutionizing the cloud solutions with Vultr. For those who are not familiar with Vultr, I'm going to spend a few minutes just reviewing who we are, kind of giving you a better sense of how we got to where we are today. First, one of the things that we like to talk about at Vultr is that even though we're an independent cloud provider, you are not giving up that global reach. With 32 different locations now across the planet, North America, Europe, Asia, South America, Africa, and Australia, it's really a case where wherever your customers are, we're able to help you meet them at that location, delivering that low latency, that high customer experience edge that typically you'd have to go to a hyperscaler for. We've been doing this for quite a while now with 1.5 million customers and over 50 million cloud servers deployed. And what this allows us to do is really work with providing businesses and developers an unrivaled ease of use, amazing price for performance, and like I mentioned, that global reach. One of the other things that we're very proud about here at Vultr is that we're the only MOC compliant independent cloud. So for those who are not familiar with MOC, MOC means microservices based, API first, cloud native, and headless. What this really is in regards to is both about how we help our customers deliver solutions as well as how we're built internally. Vultr itself is a microservices-based architecture, and there are some definite benefits to that. In terms of us being API first for deployment and orchestration, what that allows us to do is make it very easy for customers to spin up new workloads on us, whether they're bringing on new workloads for the very first time, or if they want to adopt a multi-cloud strategy and bring on, a Terraform or an Ansible setup and be able to run that in Vultr natively. And then in terms of us being that cloud native infrastructure, it gives you the full flexibility of being able to elastically scale up when your business requires it, and then being able to update that functionality as our systems continue to get more feature rich. With that, we really deliver an ability to offer you quick updates and features on a whole other faster time scale. With that orchestration, we allow you to do a great job of making sure that you get value out of what you deploy with us. And lastly, with that independently developed, deployed, and managed It allows you to replace monolithic architectures that allow you to innovate at a faster pace. One of the most important things that we want to make sure that you understand is the way that the GPU market has rapidly changed. This cloud GPU market virtually didn't exist several years ago, and for the most part, it was really being deployed almost in a bare metal fashion. With what we've been able to do recently and really start driving GPU as a cloud delivered service as opposed to a kind of thinly reskinned bare metal service, what it does is it allows all of our users to keep up to date in terms of the GPU resources that are available that allow you to make sure that you enable your value from a price to performance perspective. As I mentioned, with our 32 global locations, it really allows you to take this, whether it's training or inference, to where that workload is. It's really a case where being able to do your inference workloads as close to the data source as possible, and then the same thing from a training side, not having to move data all over the place to a central location so that you can finally be able to do the workload with us. As I discussed previously, one of the great advantages of the cloud delivery is the rapid ability for us to roll out new services that support your GPU needs. And then with the virtualization, we've been able, and fractionalization, we are able to reduce those entry costs and really allow a much broader set of developers to take advantage of these GPU resources. Before, it was much more difficult to get your hands on these resources, whether from a cost perspective, from a time delay perspective, from a bureaucracy perspective. Now we're able to deliver fractionalization on kind of standard cloud demand in minutes, having GPU available to you. And then lastly, because of how focused we are in driving that efficiency in our platform, we're able to deliver economics that are unrivaled anywhere else in the marketplace. So why are we really considering cloud GPU as an option? First of all, as the world has changed to no longer having to own a fixed asset and have it for years, it really allows you to take this on demand. If you need a workload that needs to be run daily, weekly, or even quarterly or annually, you only need to consume that resource as often as you're using it. No longer are you consuming that resource, paying for that resource, even if you only need to use it a handful of times a year. The next thing is really that shift, as I mentioned, from capital expenditures to operating expenditures. The biggest difference between what we do and many of the other hyperscalers is that predictable consistency in price. One of the biggest challenges that so many folks run into in a cloud environment is the unpredictability, whether it's a bandwidth cost, whether it's object storage access fees. Those are all the different ways for additional costs to get passed on to the user. Whereas for us, generous bandwidth is already bundled into our instances, and without object storage API call fees, it allows you to be much more stable in what your expenditure is on a month-to-month basis. Now that you're able to deploy things in this cloud method, it's no longer having to have that internal IT overhead. That case where you're now having to fill out a ticket so that you can, have IT procure this, rack this, deploy this. Instead, as I said, within minutes, you're able to get access to the resource that you need, run the jobs that you have, and be able to quickly turn that around and let that go and no longer have to pay for it. That elasticity, everyone has some type of peak season in their business, whether it's Black Friday that we're all aware of, whether it's the end or the beginning of a quarter, for accounting purposes. All it really does is it allows you to meet your workload where you need it, as opposed to having to hold on to that the entire time and pay for it the entire time. One of the great things, especially with cloud GPU, is that hybrid deployment capability. If you already have GPUs on premise or in colo, you can easily supplement that with what Vultr is bringing to the table in terms of cloud GPU, being able to handle those workloads, being able to scale up for a particularly large job, being able to get access to a newer generation of GPU sooner than you could have done on premises. And then lastly, like I just mentioned, that latest and greatest aspect, being able to get access to H100s today, where currently lead times from NVIDIA is stretching out and being able to deliver the value to your organization sooner. One of the big benefits of having Vultr as a partner is our relationship with NVIDIA, focusing truly on the full stack, not just on the hardware side, but also on the software side. What this really allows you to do is to take advantage of all of the work that NVIDIA and their software teams are doing to deliver a much more useful, much more effective, much more potent stack for your use case. All of this being powered by NVIDIA AI Enterprise and with easy access to the NGC catalog. So regardless of the type of work that you're trying to do, regardless of the type of workload that you have, being able to maximize and make that the most efficient and most powerful delivery system that we have here. As I mentioned, in terms of the fractionalization offerings, one of the great things that we do is it allows many more developers and many more data scientists to have access to these materials. So whether it's just initial stand-up and development to initial beginning training to full-scale training, it allows you to easily move from one to the other without having to change hardware and software stacks. The solutions that we're really looking to deliver here at Vultr in terms of our cloud GPUs really focus around machine learning and AI, pixel streaming, and high-performance computing. Starting with machine learning and AI, definitely one of the things that we're very happy to be working with Domino with. It allows us to deliver a world-class machine learning ops experience for all of the users with a full range of hardware from H100s, A100s, depending on your use cases, down to A40 and even A16s. It allows you to do the exact type of workload that you're looking to supply. If you need the larger cards to be able to do intensive training, if you need to be able to push edge inference all the way out there, very close to the workloads, it allows us to give you that full gamut of resources as well as full gamut of use cases. With pixel streaming and A40s, whether it's a graphics rendering or visual computing job, it allows us to deliver that full user experience now. It allows a fully accelerated instance, giving the full type of graphics acceleration, whether this is a animation rendering or a visual compute workload like a CAD or engineering type application. It allows you to replace those types of workstations and no longer having to keep them on premise and now being able to deliver those globally. And then lastly, with high performance computing, looking for all new ways to solve the problems that move our world forward. With the ability to deliver both regular x86 compute as well as accelerated GPU, it allows the HPC capability that before would have cost substantially more, as well as require a significant investment in data center space and staff expertise. With our ability to deliver the combined GPU and x86 computing, we really allow a whole new level of analytics, model training, and simulation to take place. With Vultr Cloud GPU, what this allows us to do is deliver that state-of-the-art GPU at that truly global scale in 32 different locations, being able to supply a whole range of NVIDIA's newest GPU architectures with H100, A100, A40, and A16, delivering a full set of different workloads from training to inference to visual compute and HPC. It allows Vultr to meet all of your specific workload needs. With AI Enterprise and NGC catalog, we're making sure that we deliver the very best of NVIDIA's software platform as well. That combination of hardware and software is really what allows you to make the very most of maximizing your development time and making sure that your workload runs the most efficiently. With our GPU accelerated Kubernetes clusters, it allows us to provide the best architecture for you to perform the work that you need to do. No longer are you having to worry about orchestrating your own Kubernetes clusters anymore. With our managed service, it allows you to bring on GPUs and use them for this type of workloads. And then from a cloud GPU perspective, we're able to scale up from a tiny fraction all the way to multi-card systems and clusters that allow the full range of where your workload needs to be. Is it a developer that just needs to test to make sure that all of the dependencies have been set up? Or is it all the way to we're training our largest data sets and making sure that that happens at the pace that your business needs? One last thing, especially as the data sets get larger and larger, the global bandwidth pricing that we have here at Vultr, where your account includes 2 free terabytes of egress, as well as free ingress every month. And then after that 2 terabytes of egress, 1 cent per gigabyte globally. No longer are you having to pay the significant multiple on bandwidth, regardless of where you are. In North America, in Europe, in Asia, and in Australia, global 1 cent egress is a huge change to the rest of the ecosystem. So taking a look at this from the infrastructure layer through the orchestration layer, with the Vultr ops, with that governance, activity tracking, and resource control of the compute resources, it allows you to set up both your GPU compute and regular compute all the way, and allows us to deliver you every potential resource that you need to perform the work. At our compute layer with the elastic load balancers, with the managed Kubernetes and storage, it allows you to go ahead and really deploy those cloud native applications with the global reach and the cost of performance that can't be matched. And then on top, with the Domino layer, all of these different pieces put together allow you to make your MLOps platform shine. With that, I'm going to introduce Josh Mineroff from Domino Data Labs for the rest of the webinar.
Thanks, Duncan. And I just want to say I'm really excited to be able to finally talk to you today about something that Domino and Vultr have really been working on for the last few months. So I'll jump right into it. So now we're going to give a little bit of background on Domino. Domino unleashes data science at some of the world's most advanced organizations. You could see a subset of our customers on the bottom of this slide. Some of the world's largest banks, ratings agencies, health insurers, all run their centralized data science operations on the Domino platform. And to give a little bit of context, so there's a lot of different use cases that show up for these organizations. One thing that we're starting to hear about from all of them, and this is something that I think everybody in the industry is hearing about, is LLMs. So LLMs have a variety of use cases across the industry and across different data science and AI teams. And one topic of conversation that's coming up is, do we build our own models? There's these great commercial models that are available. And what we're seeing is that for a lot of organizations, actually somewhere in the middle, where you're training or tuning existing LLMs, maybe these are open source or these are on top of commercial models, are where you're going to really see a lot of the value, right? And for some organizations, if it's a really key critical business use case, then they may build their own models. And doing any of these well requires, certainly for the training, requires a lot of GPUs, and even inference, doing live inference on the current generation of models also generally requires GPUs. So that's driving a lot of GPU demand from the teams that we work with. And that's like one of the things that we're most excited about working with Vultr on is being able to get those teams more access to GPUs to build these types of models and get them into production faster to drive real business value and take advantage of the frequently advancing state of the art for LLMs that we're seeing either in our work lives and in the news every day. The problem is that generally getting a quick win with these, right, is maybe easy. A lot of the narrative we hear about our customers or the journey they go through is maybe they have a small team of data scientists across the organization or working on a specific category of problem. There's a lot of low-hanging fruit in that area. So initially, there's 1 or 2 projects that they can pick up, they can see a lot of success with, they can maybe figure out or piece together how to actually get that out into production in the organization. The problems start to show up when they scale that team, when they scale the investment, either in machine learning and AI as a whole, or in a specific category of those workloads. And the problems that come up are really limit the velocity that you can get these models out into production. And the faster you can be building models and actually getting those out into the wild, the faster you can be learning from what's working in those models and use that to drive development of the next generation of models. And the better you get at that loop, the better models and the faster your business is going to be able to build them. So that can really accelerate the value that you get out of an investment that you're making in data scientists and machine learning resources across your organization. Specifically, we see three categories of key challenges that come up as teams try to scale. The first is in having inflexible infrastructure. So a lot of teams that start small, they start using piece together homegrown tools. Maybe some of those are not self-serve access, or the data scientists that are working on them don't have the ability to manage those at scale. So they end up spending a lot of their time doing time-consuming DevOps work. Also, if you have new people join the team, or you start collaborating with other teams, or if you're in a global organization, different small teams may have their own preferred tools that they want to use, or they may have their own pre-existing tools. You spend a lot of time trying to mesh all these together and manage them in some centralized way that's also secure enough that you can trust it at an organizational scale. The second category of issue we see is wasted work. This is what happens when you have lots of small teams that are stuck in separate silos. So maybe they're unable to find previous work that was done, or they're reproducing previous work. And if you do find out about a project that another team built, maybe they used a different tool or a slightly different infrastructure configuration than what your team has access to. And traditionally, if you're piecing these systems together by yourself, it can be really difficult, right, to reproduce or quickly get up to speed and use what they have. And you may decide that it's actually not worth doing that, right, and that you should just build the thing from scratch, which is kind of a waste of that prior work that was done in the area. The third category is in actually getting these models that you build out into production. So even if you build the perfect model, right, that is an incredible, let's say like a chatbot, or some like churn prediction model, if you can't actually get that out into the wild and it's just sitting on your laptop, that's not going to provide value to the business, right? And you're not going to be able to actually leverage all the work that went into that model to actually see some real world outcome. So making it easier, right, for teams to bridge that gap between not just the training and development of these models, but how do you get them out into the wild? How do you do this repeatedly? How do you track which models you have in production and how they're performing? Those are all things that Domino is really built to try to help solve. And the way that we solve this, there's kind of three categories of what we do. So the first is that Domino is a centralized system of record for data science across an organization. So people who are day-to-day working as data scientists and machine learning engineers or in adjacent roles will be able to, inside of Domino, do their day-to-day work. But there's also a lot of interfaces for other stakeholders inside the organization to collaborate with them. So the same way as organizations may use Salesforce as a system of record for sales, and there's certain people inside of an organization who spend most of their day in Salesforce, where other people only peripherally interact with it. Domino similarly gives you kind of the fabric to have organization-wide MLOps, right, and be kind of collecting all of this feedback and also publishing, reports and dashboards and things like that to users across the organization. The second thing is the integrated model factory. So this is being able to do everything from actually training and building these models to deploying and monitoring them, and then being able to govern this at enterprise scale and do that all in one location without having to build a kind of piecemeal solution of different tools. And finally is having this be self-serve to the data scientists who are actually running these types of workloads or doing these trainings. So this allows you to, from an IT perspective, right, you can govern one platform and the resources that are allocated to that platform. But from the data scientist perspective, they can still kind of use all of the tools that they want to use. And I'll talk a little bit more about what some of those tools are in a minute. But they could do that self-serve. So once Domino has been set up as a platform, all of those compute or data resources, right, that Domino either owns or has access to can be kind of managed at an abstracted level by IT. So they don't have to get into the nitty gritty of every type of tool or distributed cluster that the teams want to use. One example of a customer who started using Domino and saw a lot of these benefits is Lockheed Martin. Lockheed Martin came to Domino probably about 5-6 years ago at this point, and they were starting a digital transformation to support the technology strategy of America's Department of Defense. What they found were some of the same problems that I mentioned earlier, right? They had a lot of data scientists that were stuck in silos. They didn't know what other people were working on. They were duplicating work or taking months to onboard new employees. Also, the teams weren't able to actually get the infrastructure or tools that they needed for critical research. So that would delay the timeline where they could deliver results on those projects. And they were also spending about 65% of their time on data engineering and DevOps work instead of being able to do model development or other things that they felt were the core part of their role. So by switching to Domino, Lockheed was able to see savings of over $20 million annually. And they've attributed that to seeing a 10 times increase in data science productivity from being able to collaborate or kind of quickly get access to the tools they want to use, and a 90% decrease in the amount of DevOps support that was required from IT, right? So those IT resources are now free to support other parts of the organization because Domino is handling a lot of that, a lot of kind of the unique needs that a data scientist would have in terms of getting access to all these tools. And Lockheed is not the only customer to see those types of results. So some of these numbers are all from a total economic impact study that was done by Forrester. I'll let you look through some of these details, but what we see at a typical customer is somewhere around a 500% ROI over 3 years for using Domino. This is, again, for all those reasons I mentioned earlier. So just being able to be able to efficiently scale a team, to use all the tools that they want to use, to be able to do that safely at enterprise scale, things like faster onboarding or reduction in DevOps support time. So now I'll get a little bit more specific into the Domino platform. And then after this, we'll go into a demo where you can really see what this looks like. So I talked about that middle piece before, right? We have the system of record, that everything is centralized in one platform. Everything is centralized, and with the integrated MLOps, you can also see the entire life cycle of a model, all the way through development to actually getting it out into the wild, monitoring it, and then managing the model itself, and also things like the compute resources or data that are used to actually train and develop that model. Domino is a Kubernetes native application. So it runs on CNCF compliant Kubernetes clusters, right? You can run Domino workloads in Vultr. We can use NVIDIA hardware, and we are AI Enterprise certified as well to take advantage of that full stack that Vultr offers. A few of these categories that I want to touch on the right, you can see a lot of logos here, and these are certainly not exhaustive of the type of tools or libraries that Domino supports. These are just some of the most common ones that we see in our customers. So from a data perspective, Domino can manage connection to a variety of different data sources. You can generally connect to any data the same you would as from your laptop, right, or any other kind of local machine or server from Domino. On top of that, Domino offers a variety of ways to kind of centralize the management of credentials to those data sources. So through a UI, right, you can add a data source to a project. That could be done using a service account for the whole team or using individual credentials, and it will track kind of how those data connections are used. We also have integrations with all kind of the standard software tools, right? So if you want to work out of GitHub, or if you're collaborating with a team through Git, we support any Git, not just GitHub. Domino enables you to do that, so you can still get all the benefits of Domino and track kind of that version control in Git on top of the version control that Domino offers. We support a variety of languages and IDEs, as well as different tools right inside of those. You can see some of the packages that we see here, most commonly within our customers. Domino provides a environment that has a lot of these packages built in, but customers can also bring their own, or sometimes they'll customize on top of what Domino provides if they have additional tools. And finally, Domino has the ability to not just let you pick the amount of compute that you want to have access to inside of a job, like a batch job or an IDE session, but it can also spin up ephemeral, on-demand distributed compute clusters. So currently the ones that we support are Spark, Ray, Dask, and MPI, and any of those can take advantage of NVIDIA GPUs. And what this allows you to do is, instead of having to go to IT or manually figure out on your own how to set up a Spark cluster, if you want to try some kind of workload that either you just found out about or you're curious about that uses Spark, just from a dropdown, and most of these can be configured in Domino from a dropdown, which you'll see in the demo. Just from a dropdown, right, you can have access to a Spark cluster that's going to spin up, to whatever kind of limits, right, of resources you have in Vultr, and that's configurable by both the user and an admin. You'll be able to run that workload, and then when you're done, those resources will be freed up again, both to save costs and to allow other users, to most efficiently make use of whatever resources you've allocated to Domino. So that's one specific example, right? And we see that obviously with LLM training or fine tuning. Definitely that is really commonly a distributed workload, right? So being able to take advantage of, whichever kind of distributed paradigm you're comfortable with, your team is built on. We have support for Ray 2.0. That's another really common one that we see used for this use case. And the main thing I want to take away from here is that Domino allows you to kind of use all of the tools that you want to use. It's still centralized from a management perspective, and you have self-serve repeatable access to those. So if I've gotten a project running using kind of any pick one from each row set of these tools, if I invite Duncan now to collaborate with me on that project, in a few minutes, he can, be in an IDE session and we can be working in the exact same environment. So that's really powerful for getting new members of the team up to speed or getting somebody else to help you out with your project or vice versa. I think you have the context now for us to jump into a demo, and you'll be able to see what actually using Domino looks like. So here we're going to go through at a high level. There's a lot of surface area to Domino, so this is certainly not going to be exhaustive demo, but we'll show you sort of what a common workload could look like to train or fine tune some LLMs in Domino. And you'll also see the options that you have to select from some of the Vultr hardware and GPUs that you've configured Domino to have access to. Now we're going to talk about how you can fine tune an LLM. And we're going to start with the example of building a chatbot on your own data. We'll start in the Domino Project Hub, where there are pre-built templates for common use cases. Some of these are built by Domino, and these can also be built by your own team. Here, because we want to build a chatbot, we'll use an enterprise Q&A template. This will start a new project, and we'll jump right into the notebook that's been created for us. Inside of this notebook, a lot of the initial steps that we're going to need to do this project are already set up. We have all of the open source dependencies in the environment that we need. We have parameters that can point to your data. We have fields for you to put in the prompt for the background and any additional safety prompts that you want. And then we can initialize chat and the vector store and be able to play with it directly in the notebook. Once we're happy with the performance of this project also includes an app with a more traditional chatbot UI. We can come in here and see what the experience that an actual user would get when interacting with our chatbot. But let's say we have an existing project. Inside of that project, if we wanted to add any kind of fine-tuning model, we could do that with Domino Code Assist, which allows us to write code using a drag and drop interface. Here, we're going to click and use FinBERT, which is a BERT model pre-trained on financial data. Domino Code Assist allows us to look through a large variety of these models And through this point and click interface, we can configure that we already have an existing data frame we want to use, what types of columns we want, and it will spit out the actual code that we need into a cell in Jupyter. You can also use it in R. And inside of this cell, it will kind of have best practices code for doing this. Here, it also includes code to do things like push to Domino's built-in MLflow integration for experiment tracking. And if we come to that page, we can see that we could see all the experiments we've run in this project. We can click into one of those, get information about when it was run, what versions of files it was used, what hardware it ran on. And we can also, of course, see some of the metrics in here about the performance of that model when it was trained. Additionally, Domino Code Assist has the ability to provide code for automated hyperparameter tuning, here using RayTune. You can look at this code in a little bit more detail, but effectively, once we've put this code in, we're going to want to run this as a job. So this is a non-interactive session as opposed to the IDE we were just in. And here we could pick any of the hardware that we want this to run on. And this is where having the GPU resources available through Vultr can be a huge benefit, that you're able to actually go out and train these models. So here we're going to pick the GPU tier, and then we're going to choose to run this in a distributed cluster. And when we do this, Domino is automatically going to spin up a distributed cluster for us. We can pick the scaling of that cluster and how many nodes we want it to include. We can pick from the same set of hardware here that we had before. And once we run that, the results of that training are going to show up on the same experiments dashboard that we saw earlier. So we can go and see the performance of any of these models and really understand how we've gotten the results that we're putting out into the wild. Now, after we build one of these models, we want to make sure that we feel confident putting them in production. To that end, I want to talk about some of the features available with Domino Model Sentry. Here, we're going to go into a pre-configured template for compliance and risk across an organization. And what this is going to do is going to create a project, and inside of this project, we'll see that there are some pre-existing goals. So this can be a set of things like make sure that the project has been validated for bias, for fairness, and these can be a standard set of tasks that are going to show up in all of the projects that have these type of models. Once we feel like in this project we're happy with the model that we have, we can push that to the Domino Model Registry. There we'll get an overview page that you can see like this with a summary of what the model is about, some details on any inputs in the model, recent results that we've gotten out of the model or result of those tests like you saw on that previous page. There'll be version history. Domino automatically tracks all of the work that you do and version controls it by itself. You don't have to do any work on top of that. And it'll also show the data that was used or the versions of files in here. When we think we're ready to put this out into production, if we have an approval workflow in our organization, Domino supports that, so we can transition this either to staging or production. We can request a review from a specific set of reviewers. We can leave them some notes. And from the reviewer's perspective, they'll get a button in their dashboard they can click on. They can come into the project and look at some high-level details, right, about those types of analyses that were done in the project, what the results of that model were, and how well it was trained, or some example cases. Now, if we're ready to actually put this model into production, Domino supports publishing code and models that you have as a model API. So this makes them accessible from a REST API endpoint. Here we can choose to which model we want to use. So we're going to choose the model that we created. And we can also choose the deployment target. So that can be, again, any of those same sets of hardware tier that are available on Vultr, where you want to actually be running and hosting the resources behind the model. Once a model has been published, Domino also has features around model monitoring. These will look for both drift detection to see if the data and the predictions coming into that model are different than the data that the model was trained on, as well as model quality metrics to see kind of how accurate, right, or how good of a result it is based on ground truth data that you may get down the road. If you want to dig into a specific model in more detail, right, from that page, you can also, if you see maybe that one of those metrics violates some threshold, you can click on it in that UI, and that will bring you right back into the notebook in the same type of environment that you used to train that model. So you can immediately do some experimentation or try to understand why something that you're seeing may have happened. Thank you for taking the time to watch this demo. I'm now going to pass it back off to Duncan.
So to get started with Vultr and Domino today, we've got a great set of documentation that we can work with. So if you just go to this URL that we have at the bottom, getvultr.com/domino nexus, we'll go ahead and show you how to go ahead and deploy a Nexus data plane onto Vultr using our Vultr Kubernetes engine.
Great. Thank you so much, Duncan. And thank you so much, Josh. Very excited to hear from both of you. I actually learned something new in both of your presentations. So I was particularly excited to be walked through that. And hopefully you all learned something new as well. Thank you so much, all. Well, great. Thank you again. So now it's time to open up some Q&A. So let me turn to the chat to see what questions we have from our audience here today. So just give me a moment while I check here some comments, and let's do the first question here. So it looks like, Duncan, this first question is going to be from you. So Duncan, what type of compute resources are able to be orchestrated using Domino on Vultr?
Yeah, that's really one of the great benefits that Domino brings to the table. So I think everyone right now is so familiar with the demand in the AI ML world, for GPUs. So the GPU types that we have here at Vultr are, the A100, the H100, the A40 and A16s. So if you're looking to do something, from a light inference edge workload, you can take a look at something like the A16 all the way through to, the A100 to be able to get orchestrated through Domino and allow you to do those larger training loads. And we'll be adding to H100 soon enough to that as well. One of the other things that folks might not be aware of who are newer to this space is that Domino is also capable of helping orchestrate, regular x86 compute as well. So for folks looking to run models in that way, it's not just a case where it's only for GPUs, it's also for our regular optimized and high performance compute options.
Great. And thank you so much, Duncan. Looking at the chat, it looks like we have a couple of questions, Josh, that would be for you. And I'm going to paraphrase a couple of them, which is, how easy is it to stand up Domino Data Lab to get our teams operational? What does that look like from a process perspective?
Yeah, so thank you for asking that question. Actually, getting Domino up, Domino runs on Kubernetes. It's a Kubernetes native application. And the great thing about running Domino on Kubernetes, if that's the control plane or the data plane, is that that Vultr has VKE. So you already can show up and have a suitable Kubernetes infrastructure to run Domino on, and that's going to be managed by Vultr. So we have that doc that Duncan had shown at the end of that at the end of the webinar, with how we would currently do the data plane. If you're interested in installing a Domino control plane on Vultr, while we get that documentation together, just reach out to us and we can help you get that set up. But that's a pretty straightforward process.
Great, thank you, Josh. And a couple of other questions. First of all, some good comments on your demo. So congratulations, it was amazing. Some other questions on, are there best practices for integrating Domino with DevOps, your DevOps pipeline?
So the biggest way that we see Domino get integrated with the DevOps pipeline is once you've done some of the trainings of these models and you want to get them out into production. Domino can host these models directly, but we also support the ability for you to publish these models and use them in external production systems for inference if you already have something set up that you're using across your organization. That's one way that we see it interfacing. Another way is that you can base your projects in Domino on Git. So if you have other users that are working directly out of maybe Git but not using Domino, that's a common interface that we see as well. So you can still work in a project, get all the benefits of Domino, but you can sync changes and files with those users without having to do anything directly on your own outside of Domino.
Great, fantastic. Thank you, Josh. And it looks like we have one final question. And Duncan, I'm going to throw this one over to you. And then Josh, maybe you can add in on that. The question is, we have multiple data science teams working in separate locations out in EMEA and in North America. Is that two separate Domino implementations? How does that work?
So that's one of the great things about this, next revision of Domino, and I'll let Josh kind of address that. But with the great number of resources that we have here at Vultr, across our broad global footprint, that's not a problem at all. And Josh, why don't you get into the details a little bit about kind of how they can set up a single control plane and how they can then have data planes that run in separate locations.
So yeah, thanks, Duncan. That's a great intro. One of the features Domino introduced in the last year is something we call Domino Nexus. And what that allows you to do is use Domino to manage actually multiple Kubernetes clusters. So depending on what the needs of your team are, right? Sometimes you may have teams in different geographic regions that are still all working out of one cluster, and that may be fine, right? Depending exactly what you're trying to do. If you want to, or you have needs to keep data in specific locations, right, where those teams are, or even where users or customers are, Domino can, with a control and data plane model, allow you to spin up the Domino application in one VKE cluster. And then in other VKE clusters, you could do workloads that are going to be local to wherever the data is, right? And whether that's for, data transfer, like limitations from where you're pulling data from, if that's from regulatory requirements of where you want to keep the data in the same region that the data was generated. So all of those can be accommodated by Domino.
Great. Well, thank you so much, Duncan. Thank you so much, Josh. Just final question for the both of you. So Josh, again, fantastic demo, great overview. Where can folks here on the webinar learn more about Domino and Domino Nexus?
So they can actually learn more. I can share a link to our site about Domino Nexus and the Domino platform. Also, they can certainly reach out direct to any of us. They can also search for Domino on Vultr, right, and see that doc that we've put together that we shared today. And yeah, we're happy to talk to any of you.
Awesome. Thanks so much, Josh. And Duncan, final, over to you. Same question. Where can people learn more about Vultr and employing Vultr in conjunction with Domino?
Absolutely. I think for those who are new to Vultr, the best place to get a better understanding about who we are and what we bring to the table is on our website at www.vultr.com. And then the URL that I provided during the webinar, go ahead and from that location, you can, if you have any kind of initial implementation questions, you can get started there. And then don't hesitate to reach out to us and the team. We'll be more than happy to, work hand in hand to get you up and running.
Great. Well, thank you so much again, Duncan and Josh, amazing panelists and presenters. And thank you all for joining today's webinar. Again, if you have any further questions, please don't hesitate to reach out directly to us here at Vultr or directly out to Domino Data Labs. We'll also be sending a follow-up email to all of you with the recording of this webinar so you can share with your friends and your colleagues. And we hope to be in contact with you soon. Thank you so much for joining. Take care.